So, hello friends, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today, in this video, I am going to talk about effective atomic number EAN, E for effective, A for atomic, N for number. So, Z minus X and plus Y. So, Z is your atomic number, X number of electron loss during the formation of metal ion from its atom, and Y number of electron donated by the ligands. So you can calculate this with the help of this formula Fe(n) 6 4 minus. So you have the atomic number of Fe26. Now oxidation number here 2, so 26 minus 2 become 24, and then you have the 12 electrons here, so 6 into 2, so total 36. Now friends, nomenclature writing complex compounds. The formula of cation, where it is simple or complex, is written first, followed by that of the anion. You can see cation, you can see the anion. Within a coordination sphere, the metal atom as well as the ligands are listed without any space between them. So no space between the ligands. Just remember it. Different types of ligand, no space. Nomenclature naming. In ionic coordination compound, the cation is named first and separated by a space from the anion. You see the cation, you see the anion. Potassium separated by space, hexacyanophilate. Then oxidation number. If the coordination entity is either neutral or cationic, then usual name of the metal is used. But when the coordination entity is an anion, the name of the metal ends with the suffix ATE, sodium triamine trichloroplatinate, ATE. Now you can see lithium hydroaluminates, sodium hexanitrate, N cobaltate, diamine silver 1 nitrate, potassium tetracyanoaurate or tetracyanonickelate, like that. Now friend, isomerism in coordination compound. Isomerism in coordination compound, structural isomerism and stereoisomerism. In stereoisomerism, geometrical and optical isomerism, structural isomerism, linkage isomerism, ionizations, coordinations, and solvate hydrate isomerism. You can see here geometrical isomerism. Ma2b2 types molecule. Ma2b2, just remember Ma2b2. So there is two possible structures, cis and trans. Example, trans cis platinum complex. Now friend, geometrical isomerism. You can see N2H2 type compounds. So Ma2b2 type, and there is a cis and trans. Now you can see NABCD, N, for example PT, glycine or glycinol. So this is the cis and one is trans. Now 6 coordination compounds, complexes of the type Ma4b2 M plus. So trans CONH3 whole 4 Cl2 and cis CONH3 whole 4 Cl2. You can see complex of the type Ma3b3 type. So CrCl3 NH3 whole thrice. So you have this type of isomerism. Optical isomerism or stereoisomers. Other stereoisomers called optical isomers or enantiomers are mirror images of each other. Just as a right hand will not fit into a left glove, two enantiomers cannot be superimposed on each other. Now friends, 6 coordination compounds. Octahedral complexes containing only monodendritic ligands. So MAA3N and CrC2O4 whole thrice 3 minus. Tris oscillatochromium 3 anion or MAA2A2 called N, example Cl2 En. AA means 2 donor atom, En whole 2 plus. So cis dichlorobis ethylene diamine cobalt 3 chlorides or MAA2ABN, example COCl En NH3 2 plus. Now friends, ionization isomerism. Ions present in coordination compound. You can see red, violet and red. What is the change here? Sulfur is inside and bromine is inside. So bromine outside, sulfate outside. So ionization is different. Now linkage isomers. Same molecular formula but differ in linkage of the ligands. You can see nitrogen donor and oxygen donor. Now coordination isomers, interchange of ligands. You can see zinc with ammonia and copper with chlorine. Now copper with ammonia and zinc with chlorine. Hydrate isomers, same molecular formula but differ in water molecule inside and outside. Look at this example. This is hexa-equochromium 3 chlorides. Now you can see the water is outside and one chlorine is inside. Here you see tetra equo dichlorido chromium 3 chloride dihydrates. So this is dihydrate, this is monohydrate, no hydrate. Now bonding in coordination compound. Valence bond theory, crystal field theory, ligand field theory, molecular orbital theory. For remember, just start with the V, valence bond, crystal field, ligand field and molecular orbital theory, MOT. In short, VBT, CFT, LFT and MOT. VBT is very initial and then development of CFT, then LFT and then MOT. Now friend, valence bond theory, VBT. Linus Pauling, 1931. The valence bond theory satisfactorily explains the structure and magnetic properties of a large number of coordination compounds. Salient feature of theory: the central metal atom or ions has the required number of vacant orbitals for accommodating the electrons donated by the ligands. The number of vacant orbital is equal to the coordination number of the metal ion for a particular complex. Vacant orbital SPDF. I repeat, the valence bond theory satisfactorily explains the structure and magnetic properties of large number of coordination compounds. The central metal atom or ion has the required number of vacant orbitals for accommodating the electrons donated by ligands. The number of vacant orbital is equal to the coordination number of the metal ion for a particular complex. Now friends, this vacant orbital goes hybridization to form same number of hybrid orbitals. Each ligand has at least one orbital containing lone pair of electrons. Vacant hybrid orbital filled with ligand to form coordination bond. Coordinate bond is stronger if the overlapping between the orbital is greater. Now, vacant orbitals of the metal atom or ion undergo suitable hybridization to yield a set of equivalent hybrid orbital of definite geometry. Orbitals of cobalt 3 ions you can see. Vacant orbitals spt. So coordination number of cobalt 3 plus 4. So geometrical shape depends upon the hybridization of the metal orbital. sp linear, sp2 trigonal planar, sp3 tetrahedral, dsp2 square planar. D orbital used in dx square minus y square. So this is the use. And dsp3, d orbital used in dz square of inner n minus 1 shape. So trigonal bipyramidal. Just remember, this is very important. In a square planar, d is dx square minus y square, and trigonal bipyramidal dz square. You have here examples: sp silver and silver cyanide, sp2 hgi3, sp3 nickel zinc, nickel x4, magnesium x4, cadmium cn4, FeCl4, copper Cl4, dsp2 nickel Cn4 2 minus, nickel ns3 4, platinum ns3 4, platinum Cl4, platinum Cl4, platinum ns3 2 and Cl2, like that. Now friends, if n minus 1 d orbitals are used for hybridizations, then the complex is called inner complexes and not the outer complex. So orbital of the metal, inner d orbital, 3d, 4s, 4p and 4d, outer orbital. So this is the inner orbital complex, low spin paired complex, and high spin or spin free complex. Low spin paired, and high spin free complex. So inner orbital complex 3d and outermost orbital complex 4d, and 4d is high spin. So just remember this. Now friend, when a strong field ligands like ammonia and cyanide are involved in the formation of complex, then causes pairing electrons present in metal ion. This process is called spin pairing. Now friend, a structure of complex compound based on VBT. Structure of nickel tetracarbonate, formation of nickel Cl4, structure of nickel Cn4, structure of cobalt F6, structure of ammonia 6. So you can see the formation of nickel Cl4 2 minus. Oxidation is +2. Each chlorine has ion donate 2 electrons. Nickel 3 8 4s2. So paramagnetic contains 2 unpaired electrons. You can see the orbital of nickel 2 plus and 4s 4p is empty. Now sp3 hybrid orbitals and 4 pair of electrons from 4 chlorine. And this is the ligands, the weak ligands, so pairing is not occurs. So high spin complex. Now you can see in cyanide and nickel Cl4 the difference. Nickel 2 plus, here cyanide, this is the pairing occurs because this is a strong, this is weak. So dsp2 hybridized. dd means dx square minus y square. Hybridizations 4 pair of electrons from cyanides. Please. So in case of chlorine, sp3 hybridization 4 pair of electrons from chlorine. So this is the sp3. So nickel Cl4 2 minus is a square planar and diamagnetic, no unpaired electron, while tetrahedral sp3 hybridization and paramagnetic, 2 unpaired electrons. The Cn minus ligand is strong, it forms 2 unpaired electrons to pair. Now friend, drawback of valence bond theory. Does not explain the color coordination compound, cannot explain the magnetic behavior based on geometry, does not explain why some called inner and outer complex same metal ion in the same oxidation state.